Hey everybody, Mr. Dickin here. In this video, we're going to do a quick discussion on applications of quadratics. So how we can take word problems or real life scenarios that are modeled with some sort of a quadratic equation and how we can interpret the information by using what we know about mins and maxes and then apply that to the context of the problem. So before we jump into the lesson problems, I do want to highlight a few problems that might be seen on an online homework assignment. So you'll see these formats of problems. The words are probably going to be different. The equations themselves are probably going to be different, but the overall process is going to be the exact same. So for this first one, we have a bike shop has determined that when X 100 bikes are built, so X is going to represent the number of bikes, the cost per bicycle is given by this function C of X equals this. So C of X is going to be represented in hundreds of dollars. All right, so this is essentially my Y value, and that's going to be hundreds of dollars for cost. And then my X value is going to be the hundreds of bikes. How many bikes should the shop build to minimize the average cost? Okay, so minimize is going to be my keyword. If I look at this function, I'm noticing the X squared has a positive coefficient, a positive number out front. So that means it's going to be an upward opening parabola like this. And I need to figure out what is that vertex point. Now the vertex is going to give me two values. It'll give me X and C of X. Well, this one, it's telling me to figure out how many bikes. Well, how many bikes, that's going to represent the X value. So to do that, we use what we know about the axis of symmetry and finding a vertex. So X equals the opposite of B over 2A. So for this problem, my B value is negative 1.1. The opposite of that would be positive 1.1. So 1.1 divided by 2 times A. Well, A is 0.5. 2 times 0.5 is just 1. So X equals 1.1 divided by 1. So 1.1. But that's represented by hundreds, right? So the actual answer here would be 110 bikes. All right. Next one. We have a baseball that is hit upward. So a trajectory problem. So initial velocity, cool. Starting height would be on the ground because there's no y-intercept. Here's our function. T is going to represent time, and then S will represent its position. What's the maximum height reached by the ball? So we have a downward opening parabola. So that's going to be our vertex. We'll be given an X value, and in this case, S. And we want to know what is the maximum height. And that's going to be represented by that S value. Well, first thing we're going to have to do then is figure out what exactly is the X value. And then once we get that X value, plug that back in. So to find the X value, we'll do our opposite of B over 2A. So negative 160 divided by 2 times negative 16, that's negative 32. The negatives will cancel each other out, and we'll get 5 for X. And then that gets plugged in to our function for T. So when we do this multiplication, please remember, do the 5 squared first, following order of operations. So that should be 25. So we have 16 times 25. That's going to be negative 400. And then we have 160 times 5. And that's going to be 800. Combined like terms, we will get 400 feet. All right. So that's going to be the general process that we're going through for today's problems. So let's take a gander. All right. First problem. Financial analyst determines that the cost in thousands of dollars. So cost is represented in thousands. So if I get 5, that would be 5,000. Of producing bike frames is given by this equation. Man, that is a gross looking equation. Ugh. Thankfully, we have calculators here to help. Where X is the number of frames produced. Find the number of frames that would minimize cost. What is the minimum cost? All right, so if I think about this, we're going to have a parabola that opens upward. I know that because I have a positive A value. And we're trying to figure out what is that minimum value. So that's going to be my X and then my C of X values. The first question is asking, what's X? The second question is asking, what is the cost associated with that? Well, we know how to find the first answer, right? Opposite of B over 2A. It's going to be a pretty common theme here. I know my B value is negative 0.04, so the opposite of that would be positive, and then 2 times 0.00000, I think I had too many zeros, 25. Regardless, my X value there would be 800. And then we'll take that 800, and we'll plug that back in for X. Make sure when you plug this in, I'm assuming you're going to go straight to the calculator. Don't worry, I would too. Please be responsible with your parentheses when you're doing this. Otherwise, you'll get some bonkers answers. And it's asking, what is the minimum cost? It would be $24,000. Now, when you plug this in, chances are you just got 24. But we have to read the context of the problem. Please remember that the cost variable is using thousands of dollars as our units. All right, next problem. The height of a projectile. Hey, another trajectory problem. Is fired straight up in the air. The height function is 64t minus 16t squared, where h of t is the height and t is the time in seconds. The table represents the data for a different projectile. So these are two completely separate scenarios. We have the first projectile with the function, and then the second projectile with a table. All right, so the table represents the data for a different projectile. Which projectile goes higher and how much higher? All right, well, first and foremost, let me take a look at this function. Something might be jumping out to you that kind of makes you feel uneasy, and that's the fact that this is not written in standard form. We typically like to have our squared term come first, and then we write our exponents in what's called descending order. So I'm just going to take a second to rewrite this as negative 16t squared plus 64t. So now that's the exact same format that we're used to seeing. These two formulas are saying the exact same thing. I didn't change anything, just the optics of it. Well, we could find the maximum value for this, right? We've been doing that for the past few examples. The whole opposite of b over 2a. So we could find the maximum for this function fairly quickly and easily. Let's talk about the table, though. Here, I don't have a function. Instead, I've got a table of values, and I'm trying to find the vertex. Well, as I'm looking through, I'm noticing the numbers 32 show up twice, which then means the number 20 would probably show up down here. So that means whatever's smack dab in the middle, that's going to be my vertex. So my vertex is going to be 15, 36, or sorry, not 15, 1.5, 36. All right, so the question is asking which projectile goes higher. So we're going to find the vertex of this function, and some of you might have already done that. And we already know the height, the max height over here is 36. So we're going to say which one goes higher, and then it's got a second aspect, how much higher does it go? So if you want to pause the video to work this out, go for it, but I'm going to be displaying the answer here. So the first projectile is going to go higher. The maximum of this first one is 64 feet. So therefore it goes 28 feet higher, because 64 is 28 more than 36 than the other projectile. All right, that's it. That's all, folks. You know the drill. If you have any questions, do not hesitate to let me know. And as always, good luck, have fun, be safe, roll tide.